Okay, in this video, I will introduce some types of matrices. So the first thing is the square matrix. So what is square matrix? So it's from its names. Usually, square matrix is a matrix where the number of row is equals to the number of column. Okay, if row equals to m, column n. Okay, for example, A equals to 1042. So this is a 2 by 2 matrix. Okay, if it's power 3, that's a 1 2 3 0 negative 1 4 6 2 1 0. For example, 3 by 3. Okay, the number of row is equals to the number of column. So this is called square matrix. So what is a diagonal matrix? So a diagonal matrix is a square matrix, but the entries on the diagonals are non-zeros. The rest are zeros. For example, we have A. Okay, we have A11, A12, A22, A33. Okay, the element on the diagonal. Okay, a diagonal is the A11, A22, A33. So the rest will be 0. So this is 3 by 3. So these are called a diagonal matrix. Okay, so the elements inside here can be any non-zero number. Okay, for scalar matrix is actually a diagonal matrix, but the elements on the diagonal, the elements on the diagonals are equal. Okay, this one we have A11, A22, A33. So A11, A22, A33 are equals to a number. We say 1. Okay, we say K. Okay, the rest are 0. So this is 3 by 3. So I give example 3 by 3. The same goes if it's 2 by 2, 4 by 4. Okay, it follows the same rule. So the key is here. All must be the same number on the diagonal. So we say that it's a scalar matrix. Identity matrix is actually a scalar matrix, but K is equals to 1. Okay. So identity matrix for 2 by 2 we have 1 0 0 1. 2 by 2. For 3 by 3 we have 1 1 1. Okay, 0 0 0 0 0 0. So this identity matrix is fixed for 2 by 2 and 3 by 3. So what else? We have zero matrix. Zero matrix is where all elements are 0. Okay. Upper triangular matrix. Upper triangular means the element below the diagonals are zeros. Okay. So we have the diagonal A11, A22, A33. So the elements below the diagonal must be zeros. Okay. The rest can be any number except zeros. Okay. So 1, 1, 2, 1, A13, A23. So you can see a triangle here. Okay. So that's why it's called upper triangular, because it's above the diagonal. Okay, on the upper side. So if it's lower triangular, I think you can guess it. Okay, if we have the diagonal A11, A22, A33, so the element above the diagonal are 0. So there is A21, A31, A32. That's it. So now let us determine this type of matrices. The first one, A, is a square matrix. Okay, we have the diagonal. The element is only on the diagonal. and the same element where it's equals to 1. So this is identity matrix. How about B? It's given, it's still a diagonal matrix, okay, because the elements, non-zero elements only on the diagonal, the rest are zeros. So what do you think? Is it a scalar matrix or a diagonal matrix? So it's just a diagonal matrix. How about C? Yeah, it's a diagonal matrix. Is it a scalar matrix? Yes, right? Because all elements in the diagonal is equals to the same number, which is 5. So this is called scalar matrix. How about D? This looks like upper triangular or lower triangular. Yes, correct. It is upper triangular matrix. Okay, very good. Okay, now a negative matrix. So the negative matrix means we put negative on the matrix, or we multiply by -1. So if we have A equals to 4, -1, 3, 4, for example. I don't want 4, 0. So negative A means we put negative to each entries of the element, entries of the matrix. -4, 1, -3, 0. Okay. If it's 3 by 3, 1, 2, 0s, -1, 4, 5, 0, 6, 7. So the negative of B is -1, -2, 0, 1, -4, -5, 0, -6, -7. So you just put negative to each entries or elements in the matrix. Okay, very simple. Next is matrix transpose. So what happens if we transpose a matrix? Transpose means we change row becomes column and column becomes row. So what does that mean? For example, if we have a matrix A equals to 2, 3, -1, 0. Okay, you see this is row 1. Okay, this is row 2. This is column 1. This is column 2. So now A transpose, okay, the symbol is like this. A superscript T. So row 1 will become C1. Okay, so 2, 3, and then -1, 0. So we change it. Another example, we have B, 3 by 3 matrix, -1, 0, 4, 3, 7, 8, -1, 0, -4. Okay, so B transpose is equals to, okay, the first row we change to the first column, -1, 0, 4. Okay, and then the second row will be column 2, and then the third row will be column 3. So that's it. That's what we call transpose a matrix. Okay, remember the symbol is like this. Okay, now is symmetric matrix. So the symmetric matrix is related to the transpose. So if we transpose a matrix A transpose T equals to 8. Then is called symmetric matrix. It means if we transpose a matrix A, then we get the same thing A, meaning nothing changed. So this is called symmetric matrix. So this is example of symmetric matrix. So if A is given like this, so A transpose is 1, 2, 2, 4. It's still the same thing, equals to A. So this is called symmetric matrix. Okay. So next is skew-symmetric. So if A transpose, you get A, it is called symmetric. If it is A transpose, you get negative of A, so it is called skew-symmetric. So for this example, it is equals to A. So A transpose is equals to 0, negative 1, negative 3, 1, 0, 6, 3, negative 6, 0. So this is A transpose, which is this not exactly equals to A, but it's actually negative. When we take out the negative 1, so it's 0, 1, 3, negative 1, 0, negative 6, negative 3, 6, 0. So this is exactly the same as this A. So this is equals to negative A. So since A transpose equals to negative A, so this is skew-symmetric matrix. So that's it. Okay, now row echelon form, or in short we say REF. So by definition, an M by N matrix A is said to be in row echelon form REF if it satisfies the following properties. The first property said, okay, any rows consisting entirely of zeros occur at the bottom of the matrix. So if there is a row contains all zeros and 3, so it must occur at the bottom. Okay, must be at the bottom, cannot be on the middle, cannot be on the first row, must be at the last row. So if there is no all zeros row, meaning all elements are 0 on that row, it doesn't matter, you just ignore this property. Okay, so for the second properties, for each row that does not consist entirely of zeros, the first non-zero entry is 1, called a leading one. So meaning you look from, so if this is a matrix, you look from the left. Okay, look from the left, so it's 0, 0, 0. If there is, we should be at the bottom. So here you should see number 1 first. Okay, so the next, you cannot see number 2, and then 1. Okay, cannot, must be number 1 first. If it's 2, then it's not REF. You must see 1 first when you see from the left for each row. Okay, and then for number 3, for each non-zero row, the number appears to the right of the leading one of the previous row. Okay, if we have 1 for the first row, okay, and then for the second row, it must be 1 here or 1 here. Okay, it must appear to the right of the, this is the first leading one, so it must appear to the right. Okay, it cannot be here, cannot, because it's the same, it's just below, it must be to the right, not just below the leading one. Okay, so if there is another leading one, so it should be here, it cannot be here. Okay, so meaning it must appear to the left of the previous leading one. So this leading one, okay, you see it's appear to the left. Okay, so that's it, the 3 properties. So let us check this example. For the following matrices, determine the matrices to be in row echelon form or not. If the matrices are not in row echelon form, give a reason. Okay, the first one, check if there is any zeros, all zeros row, or entirely of zeros. Yes, it's here. Is it at the bottom? No, it's in the middle. In the second row, it should be at this row. So this is not REF because row with entirely zeros and 3 occur not at the bottom, okay. So because of that, REF is not satisfied, so we just make conclusion. Okay, for B, is there any all zeros row? No, so we skip it. Okay, remember properties number 1 is optional. If there is, then it should be at the bottom. If no, then okay, you proceed with properties number 2. For each row, okay, we need to see leading 1 first. Okay, let us see. On the left, row 1, yes, it's 1, leading 1 here. For row 2, yes, leading 1 here. For row 3, yes, we see number 1 first. Okay, the non-zero number. And then for number 3, for each non-zero row, the number 1 appears to the right. Okay, so number 1 here, first number 1, and then it's to the right. Okay, number 2, leading 1, and the second row appear to the right of the one on the first row. Okay, the same thing here. So this is REF. That's it. Very simple. Okay. So now RREF, reduced row echelon form. So it's the same properties as the REF. It's just that we add one more properties. Okay, what is it? If a column contains a leading 1, then all other entries in the columns are 0. Okay, now we look at the column, not the row anymore for number 4. Okay, let's check for number 1 for A. For the first property, is there any all zeros row? Yes, it's appear at the bottom, so correct. And then properties number 2, we look from the left. For first row, yes, we see number 1 first. Second row, we see number 1 first. See number 1 first. Yes, check. And then for third properties, it must appear to the right. Yes. And then fourth properties, for any column with leading 1. Okay, there are only 3 columns with leading 1 here. So column 1, 0, 0, 0. So okay. Column 2 is 1 here. The rest is 0, 0, 0. Okay, column 2. So it's correct. For column 3, 1 here. So 0, 0, 0. So it's correct. So we don't have to check for this row because there is no leading 1 here. Okay. So the fourth property is satisfied. So all properties are satisfied. So this is RREF. Okay. Let's take a look for B. Okay, for B, is there any all zeros row? Yes, it's appear at the bottom. For the second properties, must see number 1 first. Yes. Yes. And then for the third property, okay, appear to the right. Yes, correct. For each column, must contain only 1. Okay, not including 0. 0, 0. Yes. So this is also RREF. That's it. Very simple. So now let us determine whether this is REF or RREF or none of them. Okay. For the first one, let us check for the first property. Yeah, there is all 0 rows here and it's appear at the bottom. So correct. And then look from the left. Yeah, we see number 1 first, and then number 1 first, number 1 first. Okay, second property satisfied. And then for leading 1, we check it appear to the right of the previous one. So it's correct. So for each column, we check is there any Non-zero number except 1? No. So it's correct. So this is RREF. Okay, for B, is there any all zeros row? Yes, it's here. It appears at the bottom. And then from the left we see, okay, so it is reading 1 here. So second property satisfied. Third properties, reading 1 appear to the right of the previous one. And then for each column we see no non-zero number except 1 for each column. So it's correct. So this is also RREF. So the last one, C. Okay, let's check. Is there any all zeros row? No. So we just skip with that property. The second property, we see number 1 first. Oh, this is number 1. Now we see -1. So cannot, okay? Number 1 satisfied, but second property is not satisfied. So this is not REF because of what? Because second properties, -1 appear first on the second row. Okay, meaning the second property is not satisfied. Okay, that's it. I hope all of you got this.